Hi class. As we continue our headfirst leap into the Java programming language, we're ready to talk about define objects. So just like a variable is a named location in memory that can hold a supplied data value, like a person name variable holding a value like Sam, an object is like a variable, but instead of holding one value, an object can contain many data elements, and it can contain many methods that can act as actions that this object can do or is associated with. So instead of just having a standalone person name like Sam, we can add some other information about a person and some action items, some methods that let us interact with our person object. So this gives us a way to create some cohesive data that belongs together along with the actions that can be applied to that data. So in a person class, we would start out with the class statement. In the class statement, you guys have used it, but it's just been kind of there behind the scenes for our program so far. The class statement starts with the keyword class and then is followed by the class name. And normally when we're working with Java, the class name is in uppercase. Then we have an opening curly brace, and inside the curly braces is all of the pieces of information about our class. So the class we were looking at just a second ago had several different data elements like the name, the favorite color, a secret about the person. We're going to focus right now on that favorite color data element. So to declare our data elements within our class, we just use their data type and give them a name. We usually refer to our class type data as private. These data elements are going to be available anywhere within our class. They are not accessible because they're private outside of our class, and you'll see why that's important as we work through our class information. Now, a class field could be an instance variable like this one, which means that we'll create a new instance of this variable in memory for every time we create a new person object. Or they can be static variables, which means we would only create one instance of the variable in memory for all of the different instances of our person object to share. Now, after we declare our data fields, we're going to have what's called a constructor. And a constructor is just a special type of method that defines how we create an instance of our class. How do we create this object? Our constructor is normally public because we want people to be able to access it so that they can construct an instance of our class. But other than that, it's kind of a standard method. It does not have a return type. Notice, so there's no word void or double or anything like that there. So that's the big difference between an object constructor and a standard method, is that a standard method has a return type and an object constructor does not. But it does have a potential variable list, and then opening and closing curly braces to enclose any code within that method body. Now, here's some little PowerPoint information. This actually is our method, our constructor method, and when we run it outside of our class, it's going to create a memory location for our class. This particular constructor is a no arg or default constructor because it has no arguments within the parentheses. No parameters. And that closing curly brace ended our class. So let's say we want to create in memory a person, and we've defined our person object with our person class. So in another piece of code, in another class somewhere, I can say, hey, I want to create a person. And notice I'm using a person just like I would any other data type, like double or integer, because now that I've created this class, it is available as almost a data type. It contains all of the data and all of the actions associated with our object. Next, I name the reference variable, the variable name that I want to use to refer to this instance of my class. And then I set this equal to a new instance of my class. So it's a little bit confusing, but not too bad. We start out saying our data type is our class name, our variable name, and we want to give our variable a value, and that value is found by using a new instance of our person class, and we're not passing it any parameters. So we have a lot of things going on here. Our class name is required. It has to match. Our reference variable name is how we will refer to, again, this instance of our class, and then new keyword is required to create a new instance. All of this together is called instantiating, and instantiating means I've created an instance of my object. So it's kind of like spawning a character in a game. You've got a new instance there, and that's exactly what we have going on. So in memory, we've created this instance of our myPerson class. It only has the one data element, our favorite color, and we didn't supply any information for that data element, so it ends up with a value of null. And there's a lot of information in your textbook about null values, so do review that. As we continue, we worry about our class being accessed by others. We want to make sure our data that is held within our class is safe and secure. Remember, we have that secret data that we need to be adding to our person class at some point. We can do that through a process called encapsulation. And encapsulation allows us to create methods to give other classes access to our data fields. So our public methods that we create in our class can allow access to the data in our class, kind of exposes that information. And then our private data fields, our class data, remain hidden just within our class. Other classes cannot access that hidden information, but we can use it within our class to make calculations or decision-making things that we need to do based on that information. So we need that data. We just don't want pieces of data available to other classes. So we have to decide how we're going to let this data interact. Now we're going to add a Mutator method to our person class. So remember, in our person class, we only have one data element. It's private, and it's our favorite color. We have our constructor, where we create an instance of a person that's blank. It's really not got much, does it? It has this one data item that's blank. Now we're going to create a method here that allows us to give that data item a value, a color. So it will be a regular method, so we want it to be available to classes outside of ours, so we're going to set its access mode to public. This method is not going to return any data, so we're going to use the void keyword. Its method name is going to be set fav color. Now notice the fav color is exactly the same as our data element name, except that in my camel case, I've created an uppercase letter here for the first letter, and in our private data element, it's a lowercase letter. And this is a standard, so when I'm going to allow setting of a data element inside a class, I create a method in the class that starts with the keyword set and then has the data element name. I do expect a parameter to be passed, and that's going to be the new value for this data element. I'm going to take that new value, in this case, new color, and I'm going to use it to update the class field for this element. Okay, so let's think about that a little bit more. The method here, we call it a mutator. It allows class users to update this variable or mutate its value, right? Change it. Our standard naming is important, and we always pass a parameter in a setter. This is called a setter besides a mutator. So we always use a parameter so that we know what the new value should be. So here is our code again. We create an instance of our class, and then we use the reference variable, my person, followed by a period or a dot to access the methods available in our person class. We find the setFavoriteColor method and we use it, and we pass the value brown because we want to set this person's favorite color to the value of brown. Now, our first line of code created our myPerson memory space and our favorite color variable inside our person. And remember, it left it blank or null. The next line of code then is going to execute the setFaveColor method in our class, passing a parameter value of brown, and we're going to use that in our class to update that favorite color value. Now, besides a mutator, we create a method that is called an accessor. And an accessor, oops, PowerPoint issue there. An accessor is a method that's set up to give another class a value from our class. So in this case, we do want to return a value. We're going to say that this method returns a string. And then our method name again is going to be the name of the field with an uppercase letter instead of a lowercase letter at the beginning, prefixed by the word get. We don't need a parameter here because we're not going to update anything in our class with data that's being supplied to us outside of our class. We're just going to return this data value to our caller. So again, this is called an accessor because it accesses our data or gets it. So now we've added this, we can say our person class, we want to create an instance named myPerson. Then we want to set our favorite color to brown using our setFaveColor method. And then we're going to declare a variable that is going to use our accessor method. Our variable is called the color, and we've got that allocated over here somewhere else in memory. So we're going to call our method getFaveColor, and it's going to return that value brown into our variable that we created. So now we've copied that information from our class to a variable that's outside of our class. That return keyword sent that data back, and we grabbed it and kept a hold of it. Now in our person class, we created a constructor that creates an empty person instance, and then we updated it by using a mutator method. We could also create a constructor that accepts parameters, and that way we could set up our variable, or our object instance with values already associated with our variable. So in this case, we've added a constructor. So our original constructor created our person without any parameters. Now we're going to create another method that's named exactly the same, public person, but this time we say, hey, we expect a string to be passed to us so that we can set the favorite color of this person. Now this is called an overloaded constructor when we use the same name but we have different parameter values. So if we use this constructor to create a person, we would be passing in an argument of a favorite color. And then inside this method, we take that favorite color that was passed to us and update the favorite color in this instance. Here's an instance of us creating a new person, passing a variable or a parameter value in for that favorite color. Our myPerson object gets allocated in memory, and the fav color variable is included, and as we run through our constructor, we use that parameter value to update that variable value. Okay, so we're all set. Now we can also overload methods. When we're looking at those overloads like that, sorry, back up, we already said we were overloading that method. When we overload a method like that, we are taking those multiple methods with the same name and relying on the fact that they have different method signatures. And remember that from our earlier chapter talking about methods. The method signature involves the data return type, the method name, and all of the different parameters that the method expects to be passed to it. So the call to a method will be deconstructed to make sure the matching constructor is used or executed. So our overloads give us lots of capabilities. So here's our person class completed, or mostly completed. We have our class name. We have 3 variables. This object has only string data types, but we could have any data type included here. We've made all of our class variables private. Again, they belong to the class. We have 2 constructors. We will allow our class to be created empty with no parameters, or we will allow our class to be created with a person name, favorite color, and secret all being supplied. We'll take those values that are supplied and update, if you notice, our class fields with those values. We have a setter and a getter set up for our person name. We would have the same thing set up for our favorite color. We would not have a getter set up for our secret because we would want to keep it secret and only within our class, and we don't want other classes to be able to access that. So we can use our getter and setter code to control that kind of thing. So up at the top is our class data, then our constructors, and then our accessor mutators for our different fields, in this case just our person name. So accessor mutator, getter, and setter. Now we can also use our class definition to create multiple instances of the same object type. So here we're creating 2 different person objects, one named myPerson, one named Jerry. These different people are being supplied different data values like people. So our myPerson object would be allocated, then our person name field would be set up with that parameter value. Our favorite color be set to green, and our secret would be set to that sensitive data value that was passed to us. Then in the next line of code, our Jerry person object would be allocated, and his person name would be set to Kyle, his favorite color to purple, and his secret to credit card info. So if I wanted to know information about Jerry, the way that I would access things is I would use my instance name here, Jerry, followed by a dot, followed by the field name, jerry.favcolor. I'm going to get rejected, right, because favcolor is private. But if I do jerry.getFavColor, then I'm going to be able to get that information out of my class. So we're going to be working with classes a lot, and this is kind of an intro really quickly, and I know you guys can handle it. When we're working with class information, we'd like to document that information somehow, and the UML document or diagram gives us a standard way to do that. And UML stands for Unified Modeling Language, and you can do some Googling and find out all sorts of information about it. This picture shows a bunch of different symbols that are available for UML diagrams. It's a lot like a flowchart. And just like a flowchart, there are a lot of different tools available to use for drawing UML diagrams. We'll come back to that in a second. Now, over here on the left, I have some standard UML rules. We start out with the class name at the top. Then we always include an indicator of the access mode or visibility. So if I have a plus sign before the name of something, that indicates that I set it to public. If I have a pound sign, it's protected, and if I have a minus sign, it's private. And all of those access modifiers are things that we've just been using a little bit, and we'll be talking a lot more about as we start sharing data across classes. That's when all that starts mattering. Now, the top section then, under the class name, is a list of all our data elements, our class fields or attributes. So in our case, we had person name, and that's a string. We had the fave color as a string, and the secret is a string. That should have a lowercase s, sorry. But each of those are private, so the minus sign is set here that way. The next section then of our object model is a list of all of the methods or actions or operations that are available for this object. So we would have a set person name. It would be public, and it would expect a parameter of the new person name, and it would expect that parameter to be a string, and it would not return any value, so that's void. Then we would have a get person name method. Again, it would be public because it's going to be available to classes outside of ours, and that's going to return a string. We have a set fave color. You can see its information and get fave color. And then down at the bottom we have our constructors, both listed. So our person constructor with no variables or no parameters, and then our person constructor with all of the different parameters. So the UML diagram is kind of just a list in a standardized format of all of the information that has to do with this class, and you'll see that information in our textbook. So for you do have a UML diagram to create for this week, so you can use cloud-based diagramming tools like Creately. You can download Visio from Microsoft Imagine. You may have already done that for your 120 class, depending on if you needed it or not. It can be a little difficult to download, but then it's a nice tool to have. You can also use your development environment like NetBeans to generate somewhat of a UML diagram. We'll take a look at that. So lots for us to think about as we begin trying to actually program for real things, for objects. I'll be back with some examples for you. We'll work through some of the exercises at the end of the chapter. Thank you.